हाँ, आज हम लोग मतलब specially today I am going to discuss about some minute concepts for class 11 as well as for class 12. 12 और 11 दोनों के लिए हम पहले तो मैं 11 से स्टार्ट करूँगा। सब कुछ माइन्यूट कॉन्सेप्ट, जैसा कि आप ये माइन्यूट कॉन्सेप्ट जैसे आप वर्क पावर और एनर्जी में क्लास 11 के जो चैप्टर है वर्क पावर और एनर्जी में, वहाँ पर क्या है कि पोटेंशियल एनर्जी के बारे में बताया गया है। तो पोटेंशियल एनर्जी जैसे सभी लोगों का एक कॉन्सेप्ट होता है, पोटेंशियल एनर्जी मतलब mgh, ये हाइट के कारण एनर्जी आता है। ठीक है, ये बात भी सही है, लेकिन इसका जो एक माइन्यूट कॉन्सेप्ट है, कॉन्सेप्ट ये है कि पोटेंशियल एनर्जी आता कब है, कब किसी के शरीर में पोटेंशियल, किसी के बॉडी में पोटेंशियल एनर्जी आता कब है। जब एक फोर्स एग्जिस्ट कर, पहले ही एक फोर्स रहना पड़ेगा। ओरिजिनली देयर अ फोर्स मस्ट एग्जिस्ट, एक फोर्स तो ओरिजिनली रहना पड़ेगा। और अगर उस फोर्स के अगेंस्ट में किसी भी चीज़ को अगर एक जगह से दूसरे जगह अगर हम ले जाते हैं, उस फोर्स के अगेंस्ट में, if you bring a body from one point to another point against the existing force, then you have to do an external work done, and that external work done is stored in the form of potential energy in the body which you have moved from A to B. So this is the concept of potential energy. So for potential energy, and there must be an existing force, and you have to move the body against that existing force from one point to another. And when you move the body against that existing force, then you have to do an external work done. So that external work done is stored in the form of potential energy in that body. Now suppose when we lift a body which is lying on the floor, when let us lift a body, let us lift a book or some object which is lying on the floor, and if we lift that body from the floor to the top of the table, when we place it on the top of the table, then we are doing work against the force of gravity. That is the force of gravity, that is the weight of the body which is acting downwards towards the center of the earth. We are working, we have to do a work that is against the force of gravity. That means when we lift the body from the floor to the top of the table, we are doing a work which is against the force, gravity force, and that work done is stored in the form of potential energy in the body when we place it on the top of the table. So now there a question arises which most of the students ignore. They just keep in mind that potential energy is nothing but it is mgh, that is the it is energy which is gained due to the height, but they do not go to the depth. And so today I am going to deal with the depth. So one must think about it. When you lift the body, that means the external force must be greater than the gravity, then only you will be able to lift the body from the floor, from the floor to the top of the table. Your external force must be greater than the gravitational force. But what we do, we directly tell that the work done by the external force is equal to the weight of work done by the external force is equal to the work done by the gravity force. How this is possible? Because if you have to lift the body, the force, that the external force must be greater than the gravitational force, then only you will be able to lift that body from the floor to the top of the table. So what actually happens that according to the theory, this is purely theoretical, when you lift the body, you move the body very slowly such that your acceleration is zero. So you know that you have learnt in motion chapter that when a body is uniform motion, there is no external force, that is the external force is equal to the force of friction. So same is the case here. When you lift the body from the ground, you lift it very slowly, such that your acceleration is 0, and at that time your external force is equal to the gravitational force. So this is the main factor when we write it, that the work done by the external force is equal to the work done by the gravitational force, but we give a negative sign because the force is acting in a direction opposite to the motion of the body. That is why we take the work done by the external force is equal to the work done by the gravity. This is the main criteria, this is the main basic point which I want to tell you, that is that when you lift the body, you move it very slowly so that your acceleration is 0. That means your acceleration is 0. At that time your external force is equal to the gravity force. Therefore we are able to say that we lift it very slowly, so and bring it on the table, on the book or the object on the table, so we are able to take that this external work is equal to the work done by the gravity, but with a negative sign, that is which states that the force of gravity is working in the direction of the force of gravity is opposite to the direction of the force. Now again, this work done is stored as potential energy. So now here your external work done, that is equal to, that is Fx dx, that is Fx d, that is the external work done, is equal to the, or Fx into h, that is the height which you have lifted it, that is equal to u, that is minus mgh, that is the work done by the gravity. Now you see again, this work done is stored as potential energy in the body. So that potential, so now this work done so becomes potential energy, so your potential energy becomes plus mgh. So this is the root, and so we take that the external work done is equal to the work done by the gravity. Now again, why didn't we consider the external force? We consider the gravity force, because the gravity force is a conservative force and it depends on the position, not on the path. So we take this potential energy as mgh. This is the main factor which I would like to explain you, that why the work done by the external force is equal to the work done by the gravity. Now this is all about your class 11, and this is the base concept. Now here one more thing I want to tell you, that is about wave, that is your for class 11. Most of the student, it has been found that you feel little bit headache to learn about wave, you feel it it's little bit difficult to understand, but after this is wave, it is an interesting topic. Today I am going to deal with some important factors. Later on I will give you the detail on this chapter, but for today I am going to just deal with the main facts, that is wave, that means sound wave. There are two types of waves, one is the transverse wave and other is the longitudinal waves. We are dealing with the longitudinal waves because the sound waves is a longitudinal wave, so we are dealing with the longitudinal waves. Now here, to explain the wave, we have considered it as a, it will be better to make you understand if it is a transverse wave, it makes it better to understand. So this wave, that means sound wave, it requires a medium. So the medium, the most important point is that the medium, so the vibration of the medium is necessary, which enables the sound wave to propagate. That is the vibration of the medium, that is the vibration of the particles of the medium is necessary for the propagation of the waves. This is a very important factor. So here you see that the vibration of the particles of the medium. It is better to make you understand. If you consider a transverse wave, it makes you better to understand, because to form an equation in a transverse wave, it is very easy. So you can say that no doubt in longitudinal waves, the sound waves, it travels along the direction of the motion of the particles of the medium, no doubt. But here you see that motion of the particles, that means the motion of the particle is the main guideline to let the wave to move in the forward, sound wave to move in the forward direction. So here you see that what is the important point here, you see that the vibration of the medium is the main guideline. That means it guides the sound wave to travel in the forward direction. So if you can say, also you can say that as the particles of the medium vibrates, the sound waves propagates in the forward direction. So to make an equation, it is possible that to make an equation to describe a sound waves, to make an equation that is y bracket xt, that is equal to a sine omega t minus kx. This is the equation of the wave. That means we are telling the equation of the wave. Actually this is the motion of the particle with respect to position time. That means it is the motion of the particles in y direction, motion of the particles of the medium in respect to position and time, in position, that is x and t. This is the main equation, that is y bracket xt is equal to a sine omega t minus kx. That means you can think like this, not perfectly, but you can think like this, that the wave will be moving in a direction in which the particles of the medium will be vibrating. That means if you see that in a river, ripples are created, and if you put a paper on a ripple, that means paper will move according to the direction of the ripple. That means the ripple produced in the water, that is the wave which is produced in the water. And wave means not the wave, that means I want to say the motion of the particles of the water. As it moves, the piece of paper, it also moves with the in the direction of the motion of the particles, and it moves, the paper moves forward. So what I want to stress is that why the propagation of wave, to form the equation of the propagation of the wave, it has been taken the stress on the motion of the particles of the medium. That I want to tell you. That means you can think that the waves are moving in as the particles of the mediums are moving, and it is moving in the forward direction. You can think it of like this. So that means so it has been given stress on the motion of the, that is the movement of the particles of the medium, and which represents a wave. So it has taken the it represents a wave. This is the main factor. So your equation is y bracket xt, that is equal to a sine omega t minus kx. Now here your a, it is the amplitude from the mean position. That means x-axis is considered as the mean position, and the displacement from the x is called amplitude, and omega, it is the angular frequency, x, it is the position of the particle in the along x-axis at time t. And so by the help of this we can locate the motion of the particle with respect to t in y direction. We can locate the motion of the particles in x-axis, lying on the x-axis with respect to time along y-axis, and that motion of the particles will determine the movement of the wave. You can think it like this. That means the The wave, that is your sound wave, it will move along the motion of the particle of the medium, and it will move on forward direction. So that is why the equation of the wave is considered as the motion of the particles of the medium. So this is the only way to express a wave. Now so I want to clarify that why they have taken the equation of the wave y bracket x comma t, that is equal to a sine omega t minus kx, where k is the wave number and a wave number. This is the main basic of a wave. Now here there are other factors, the other things are also described in your textbook, but I am going to consider only few particular points, that is the few particular points, that is one is the Laplace correction, and other is the vibration which takes place in musical instruments, especially in pipe organs. So here there are other topics also, stationary waves, and beats. There are other topics, but today I am going to deal with only these three topics. Later on I will give a full details in this chapter, but I have taken only these 3 points because most of the students feel little bit difficult to follow the wave, and so to make it interesting and make the basics concept, I have taken only the three topics. That is, first I have just now explained about the wave, how wave is represented, and next it is the sound wave. We all know that it is a longitudinal wave, and this sound wave, here the sound wave, as we according to Newton, that is, when the sound wave travels in air medium, there is a compression and rarefaction of the medium, and during the compression and rarefaction, according to Newton, he considered this as an isothermal process. That means the temperature remains constant when during compression and rarefaction of the medium of the air medium. And according to him, the velocity of the sound is root over p by rho. That is, p, it is the pressure, air pressure at STP, and rho, it is the density of the air. And when it was calculated, we find that it is 280 meter per second, which is far away from the speed of the light, that is 330 meter per second, which we considered. So Laplace, he corrected it, and he said that during compression and rarefaction there is no transfer of heat. He considered this as an adiabatic condition. According to Newton's, he considered it as PV is equal to constant. He considered it as an isothermal process, and he considered PV is equal to constant, where Laplace, he stated that during compression and rarefaction it takes place so fast that there is no transfer of heat. So he considered it as an adiabatic process, and he considered PV to the power of gamma as constant, where gamma is equal to Cp by Cv. So and according to him, the velocity of the sound in air is root over gamma p by rho. So where gamma is 1.4, and when it was calculated, we found that it is 331 meter per second, which is more perfect than the Newton's theory. So this is about Laplace corrections. Now the last most interesting point, it is the sound waves in musical instrument. That is, in musical instrument, the pipe organ, it is constructed in such a way where the pipe organ, which is open on both the side, you have found that the flute, in the flute you have found that when you blow inside the flute, there is a inclined plane. An inclined plane, when you blow the air, it gets reflected to the inclined plane, and when it moves out of the pipe, there is also an inclined plane where it strikes with the with that inclined plane and vibrates. That means when it strikes, a sound is produced, and this sound vibrates the air column inside the pipe. See, this is most very interesting. What happens in an organ pipe when this, I am considering the organ pipe, that is, which is open at the both end, which you mostly use while in pujas. Most of the students, children playing with the flute, which is open at both the end. And even if you have found in orchestra, that is, they are playing with the flute, which is open at both the end. When you blow the air, that is near it, there is an edge, inclined plane, from which it reflects and moves outwards of the pipe, where there at the outward it is also an inclined surface. When it strikes the outer surface, it vibrates and produces a sound, and this sound vibrates the air column, that is the air column present. Air column of the pipe. It vibrates the air present in the pipe, that is the air column which is present in the pipe. It vibrates the air, that sound. That means you have already learned that any vibrating object produces sound. So here, when any vibrating object, when you blow, then when you blow it, and as it strikes the when the air moves out of the surface of the pipe, there is a inclined surface, and as it strikes the inclined surface, it starts vibrating. That means vibrate. The air vibrates, and this air vibrates means produces a sound, and that sound, it vibrates the column of air present inside the pipe. And according to the frequency of the vibration of the air column present in the pipe, we get the sound. According to frequency of vibration of the air column inside the pipe, we get the sound. So here, this is how sound is created in a pipe, in a musical pipe. And now, what is the interesting point is that you can increase the frequency of the sound wave by considering more nodes and antinodes. You can increase the frequency of the sound waves, and this way we get the sound in a musical instrument. So here, how sound is produced, that is the main point. And the things which I have discussed now, this you won't get in the book or anywhere. This is the main analysis, that when you blow that air, when it moves out of the surface of the pipe, there is at the opening, the surface is inclined. It strikes with the inclined surface and vibrates, and this vibration produces sound, which vibrates the air column of the pipe, and we get the sound. So by the help of increasing the nodes and antinodes, we can increase the frequency of the sound, and as the increase the frequency of the sound, and by increasing the frequency of the sound, we get the required frequency. We get the frequency which we require. So this is how a sound, sound is created in an open pipe. So sound is very important, and it uh, in any musical instrument you will find sound waves. It is a sound wave, it is after all it is an energy. What is sound wave? It is after all it is an energy, and you have already learned that any vibrating object produces sound. When you vibrate an object, it produces sound. So when the sound strikes the inclined surface at the outlet of the pipe, it vibrates and produces a sound. That sound vibrates the air column, and as per the frequency of vibration we get the sound, and we can increase the frequency by introducing more nodes and antinodes. And even if we increase the length of the pipe, we can increase the frequency of the sound. So I think so you are now clear with the organ pipes, how sound is produced in an organ pipe. Now next is the beat. The beat, this is also you all, this is the difference in frequency actually, and this is also you have seen mostly who are playing with musical instrument. What happens that if you have to tune the strings of the guitar, what does you do that a person holds a note in a harmonium, and the guitarist try to adjust the frequency, and when the frequency becomes equal to the frequency of the pressed note, then the frequency of the string is adjusted. So the difference in earlier, so at earlier the difference in frequency which was existing, that is called the beats, and that is called the beat. So these are practically it is used, and it would be better if you have some theory practical experience, then you will be able to grasp it more easily and have a good concept in this sound wave. So today this is all about for class 11, that is this is all about class 11. First of all, I told about potential energy, because the potential energy, most of the students are of the concept, they take a plain concept, that is potential energy is due to height and mgh, and they do not see the depth of it, and if you read the book it confuses it, how this external work done is equal to the work done by the gravity. So I have tried to make it clear for class 11. Later on other lecture I will give you the details in waves, all the theories in wave I will give you later on, but today this is all for class 11.